Everyone, in this video I want to show you how you can graph series on Desmos. So here I want to show you what a power series would look like. You can do any series you want. You can do arithmetic, geometric. But you may have graphed series that look something like this. So this is called a power series because you're dealing with powers. And what I want to show you is this feature here where you can write sum and this capital sigma pops up. So on the bottom you would write which term you want to start with. So in this case, let's start with 0 because we're going from x to the 0th power. And then we're going to work our way up to x to the 3rd power. So that's going to be what goes to the top value and right, x to the n, because that is the variable that we are iterating on. And so that you have a better view, right, this is the exact same equation, which is why the dots are riding on top of this line here. I'll put this in a folder. And what I want to show with power series is how you can use Taylor series, which is a special kind of power series. And why you want to use Taylor series is if you have a complex non-polynomial equation, it may be a better idea to use Taylor series to do it. And just for demonstration, I'll use e to the x. And as a side thing, look out for a poll that that asks if you want to see a video explaining how this works. So this is just a demonstration. Right, so we have e to the x here, and we're going to start with one term here, y equals 1. Right, and it's only one term. It's not a really good approximation, but then if we start adding terms to it, you can see that the accuracy improves, and so adding a linear term makes it a tangent line. Adding a quadratic term makes it a better estimate. You can see now that, say, from 0.2 to positive point, from minus 0.2 to positive 0.2, the accuracy improves. And let's just add a few more just so you can see the accuracy gradually improved. You can see now that, say, from about minus 1 to 1, this polynomial hugs the exponential curve pretty well. And so let's condense this into a summation. So we're going from 0 to 4. As we still have exponentials, right? X to the 0 is 1, x to the 1 is x. And we start x squared, third, fourth. And what goes on the denominator is a factorial. Again, if you want to see an explanation on how we derive these series, do vote. And the advantage that we get here, so this green line is right now is the exact same equation as what you have on the top here. But now if you just throw on, say, I want to pick 10 arbitrarily, you can see just how much better this improves, and also saves you a bunch of writing. Right, and this equation will be available in, well, this graph, the link to it will be available in a description. And if you join as a member, you'll also have access to projects to videos that are posted are the members only, and so you get that benefit. You also support the channel, and so if you do join, thank you in advance. And so I would like to demonstrate one more Taylor series, and that is the sine of x here. And this one does get a little more complicated since I'm just gonna first one. I prefer to start with 1. 0 also works, and I'm just gonna go up to 3 for now. And go with -1 to the power of n minus 1. And this will alternate between, so this will now start with +1, next term goes to -1. And this is x to the 2n minus 1 because the exponents are odd. I think if you started with 0, you'd be using 2x plus 1. And we would divide this by 2n minus 1 factorial. And if you throw in more terms, let's zoom out so you can see more of this. I would say, let's do 20 terms. You can now see that for, let's call this -15 to +15. If I just showed you this equation, you wouldn't be able to tell a difference if this was a polynomial or if this was an actual sine curve. All right. Again, link to this video, or not this video, but this graph is in the description. So if you found this helpful, do leave a like. If not, let me know in the comments what you would have liked to see. All right. Hope you enjoyed, and I will see you in the next video.